Hey everyone, welcome back to my YouTube channel. So, over the past few months, I'll say, a lot of people has asked me, reached out to me, including my friends, my juniors and my ex-colleagues, asking how I was able to crack interviews of so many product-based companies, right? And they also asked me how I think during my DSA rounds and how do I approach problem from scratch. And every time when I explained it, I realized one thing that most of the people don't struggle because they are bad at coding. They struggle because, they don't have the clarity of what needs to be done. Okay. No one has told them, or like they don't have that much of guidance regarding the same thing. Okay. So I thought, why not create a place where I can break down things slowly, you know, starting from the brute force, then building up the intuition step by step, and then moving towards the optimized solution, just like I do in the interviews. Okay. So these videos might be long and you know they'll be a little bit boring as well because so much talking will be there, but you need to know one thing, that they are made for students who are going to get in this interview season that is coming in next year, right? The working professional with you know a source where they can revise their stuff. Okay. And the beginners or the people who are trying to do the career switch, moving to the IT industry and trying to learn DSA. So if this helps, even a few people to become better at problem solving, I'll be really happy. So yeah, without wasting any time, let's get started. So we have a problem statement here, continuous subarray sum. So what's the problem statement? Given an integer array nums and an integer array k, integer k, return true if nums has a good subarray or or false otherwise. Okay, a good subarray is a subarray where its length is at least 2 and the sum of the elements of the subarray is a multiple of k. Note that a subarray is a contiguous part of the array. An integer x is a multiple of k if there exists an integer n such that x equal to n into k. 0 is always a multiple of k. Okay, so let me share the entire thought process that I always have during the interview problems. So first thing that would have come to my mind is, okay, the arrays, we are asked subarray. So what is subarray? Subarray is a continuous part of array. So this 23, 2, 4, 6, 7 individually are a subarray. 23, 2, 2, 4, 4, 6, 6, 7 are also subarray. 23, 2, 4, 2, 4, 6, 4, 6, 7 is also subarray of length 3. Then we will have subarray of length 4. So this one and this one and so on. Okay. Next is an integer x, second part of the note. So do you know 6 into 1 equal to 6? 6 into 2 is equal to 12. So if my x is 12, then n is 2 and k is 6. Okay. Simple as that. Now moving on. So what will I ask my interviewer? Okay. Now this is something that I talk out loud. Now I'll ask my interviewer, like, if the array is subarray, okay, so tell me what are the constraints. Are there any negative number or all the positive numbers are there? Do we have the array with the length of 1 or less than that? So reason behind is the length question why I asked is sorry, not less than 0, 0. Okay. Now the reason behind is key, because a good subarray is this array, good subarray is the one with the length of 2. So if we have a length of 1 subarray and it is somehow multiple of its given value k, then it should not be considered as a subarray, right? Good subarray. We should return false in that sense, in that scenario. Okay. Now when I have all my questions cleared, so always remember, always ask the question. Do not think like if it will make you feel dumb or anything, right? It's an interview, it's a two-way communication. You are supposed to ask the clarifying questions. So always do that. Okay. Always ask the clarifying question before moving ahead with your problem, or without moving ahead with the solution that you have in your mind. Now moving on to the solution. So first I'll think of a more of a brute force approach. So here we need to divide the problem into sub problems. So first of all, what we need to find is subarrays of length greater than 2. Okay, then we need to find the sum of those subarrays, and then we need to find out the subarray with the minimum length, which has okay, we don't need the minimum length here. So yeah, we need to find the subarray which will be divisible by k. So to find the subarray divisible by k, we need to find the sum of that subarray, then use mod operator. So sum mod k, if it is equal to 0, then that means the subarray, the sum of the subarray is divisible by k, and that subarray is a good subarray. Okay, so take some time and try to find a way to get all the subarrays, like all the small arrays inside the subarray. Okay, pause it for a while and try to think of a way. So I'll give you a hint. Try to use looping system. Okay, if you can use loops, how will you use loops? And yeah, pause the video again and try to find all the subarrays. So yeah, if you thought of using two loops, then that's a very good thing. Okay, you are on a correct path. So you will ask, why two loops? Okay, so when we are doing the brute force approach, so in arrays, basically the brute force approach lies as either recursion or using more than one loop, because big O of n is the time complexity when we are iterating the loop once, but when we try to iterate loops again and again, then the complexity exponentially increases. So if two loops are there, n square will be the time complexity. For three loops, it will be n cube, and so on. Okay, so as you asked for the constraint, like what was the length of the array that you can expect, so I think I forgot to ask this question, but yeah, this will also be one of my questions, like what is the length of the array that I'm dealing with. So when you are giving the interviews for the product-based companies, the length of the subarray that they will be giving you is 10 to the power 4 or 5. Okay, doing two loops, then think of it like it will go 10 to the power 8. For three loops, it will be 10 to the power, oh no, not 10 to the power 8. For two loops, it will be 10 to the power 2 into 4, so 8. Yeah, 8. For three loops, it will be 10 to the power 4 into 3, 12. So yeah, it will keep on increasing, and you don't have that much of, uh, liberty to have that much of time complexity. Okay, so you have to optimize it. So before wasting any time, let's start with the coding of the brute force approach. So in brute force, we will be generating every subarray. The outer loop selects the starting index I, the inner loop selects the ending index, so it will be j, it will be greater than or equal to I, and then it computes the running sum. Okay, so for each ij pair, we check the prefix sum. If modulus of k equal to 0, then it is a good array. So let's pause this video and you try to code it on your own. Try to find, so first before going through anything, try to find all the subarrays first. Okay, I'll be writing the entire code, but yeah, let's skip it, and we'll write the program to find all the subarrays first. So I'll be coding in Python, and this is my you know this is a way to write a two-way loop in Python. So yeah, you can see I have started my loop for I in range n. Then in my inner loop, I have done for j in range I to n, and then I have printed my nums of I to j, and this will give me all the subarrays. Okay, so most of people, what they will be doing is for I in range n, and then for j in range I plus 1 to n. Okay, so think of it as a perspective from the edge cases, and then tell me if it will give you all the subarrays or not. Okay, don't do anything, just pause the video, try to run this, and you can mention it in the comment section, like what was the missing thing. So basically, first I used to do this, and this kind of messed up my subarrays, and this is a valid case of avoiding your edge case, which is not right. Okay, so skip that. Now this is my two-way loops, and nums of ij will give me all the arrays. So what I'll do is key, if j minus I, so I'll store it in my temp variable, nums of I to j. Okay, So basically I'll be skipping the code part because I need to keep this video longer for explanation, not for the coding. So yeah. So see, uh, I stored my subarrays in temp. Then I made sure that temp is divisible by k. Sorry, the sum of temp is divisible by k. And then I also checked if my j minus I is greater than 1. So this is the condition for good array. Then if it is all true, then we return true. If it is not, then we return false. Let's run it. And you can see there is an error. So yeah, actually I wanted to show how people just use num or instead of nums. But yeah, I mentioned array over here because I wanted to clearly change the name. So this is one of the issue that happens when you are given the code snippet, but you have habit of writing code on your own as well. Okay, so always avoid that. Oh, sorry, the debugger. Now we run it. So you can see this is running, but as I said, the time complexity will be a lot here, so it will go to big of n square, which is not right, which is not suitable. Okay, so let's try to optimize it. So before we go with the optimization, I want to share one tip with you. Okay, so I'll pause the video and try to think of it on your own, but before that I'll try to show you one trick. Okay, so you have I, you have sum, and you have your remainder. Now your I is at 0, your sum is 23, and your remainder is 6 4 are 24, 6 3 is 18, so 5. Now you are at index 1, your sum will be 25 and your remainder will be 1. Okay, let's skip to the end. So yeah, if you see in your ith index, when it is 0, the sum is 23 and your remainder is 5. So what do I mean by remainder is sum modulus k. Okay, so whatever the remainder will come, it will be here. And for 1, it is 25 and remainder is 1. For 2, it is 29 and remainder is 5, and so on. Okay, so if you see wherever the remainder is 5, wherever the remainder is coming in as 5 after the first one, we can see the sum of that subarray is divisible by k. So 2 4 is 2 4 6, it is divisible by k. 2 4 6 is 12 and it is divisible by k as well. So pause your video for some time and try to find a relation between it. Okay, so basically what is the reason behind this is ki I'm talking about why the subarray between these remainders have the sum divisible by k. So if two prefix sums, okay, so 2 4 6 2 4 and 23 2 4 and 23 2 4 6 are the prefix sums. Okay, so between, if the two prefix sum have the same remainder, so 23 2 4 and 23 2 4 6, okay, and even 23, if this two prefix sum have the same remainder, then the subarray between those prefixes, like the starting and the ending, the subarray between that has the has the sum that is multiple of a k. Okay, if yeah, like you are a little bit confused by the definition, try to see over here only. Okay, so whatever the subarray that is coming between these two are the prefix sum. So 2 4 is a 2 4 is a divisible by k, like sum of 2 4 is divisible by k. Similarly, sum of 2 4 6 is divisible by k, and where they lie is between 24 and 4 and 6. Okay, so between 23 and 4, 2 4 is a subarray. Between 23 and 6, 2 4 6 is a subarray that has a sum divisible by k. So try to find a way like how you can store the remainder and in which index it is coming. Okay, so try to think of a data structure that you can do that. Okay, so I hope you have found a data structure that can do that. So if you're thinking of hash map or in Python, or dictionary in your dictionary in Python and hash map in your Java, C, C++, then you are absolutely right. So we talked about storing the remainder with its index in which it is coming. So what is the best data structure to do that, so that we can like quickly retrieve the index in which we have received the current previous index in which we have received the current remainder. So let me be clear. So where we can find the index, previous index this in which we have the correct current remainder. So if we are talking about 5, then this is the current remainder, and where was it previously found, what is the index of that. So previously found remainder 5 was here and its index was 0. So you can store it as 5 colon 0. So key will be remainder and value will be its index. Okay, now remove all this, scratch all this. So we said we'll be using a hash map. Okay, now for I in range n, so what we will doing, we are about to store the remainder with their index, right? So what do we need to do here? We need to find the current sum. Okay, so the current subarray sum and divide it by k. So to store sum, like we need to store the prefix sum. So what prefix sum is? 23, then 23 plus 2 25, then 25 plus 4 29, then 25 plus 6 35, 25 plus 7 42. So this will be the prefix sum. To find the prefix sum, we need to have a variable which I'll be naming somewhere. Okay, it will be initialized to 0. To find the prefix sum, I just need to add my index, like elements in the particular index, and then what I need to do, I need to find the remainder. So let's name the variable remainder. Now some variable modulus k. So what we were supposed to do, we need to check if the current remainder, if it is already in our hash map. So if hash map for Python it's dictionary. Okay, if remainder is in hash map. Okay, and we also need to check the if it is a good array, we need to also know if the distance between these two indexes, the current index I and the previously found index with the remainder. Okay, if it is greater than 2, greater than equal to 2, then only it's a good array. Okay, so if remainder in hm and absolute of the current index I minus hm of remainder. So we don't need absolute over here if we are doing I minus hm of remainder, but yeah, let's go with it, is greater than 1, then we return true. Else we need to add this particular remainder in my dictionary slash hash map remainder. And what we said, what will be the value, key value in that hash map? Key will be the remainder and value will be its index. So I, let's make it better, idx and over here as well. Yeah. Okay, now if everything is done, okay, now what we need to do is we need to return false as well, because we did not find any what it is called subarray, right? With we didn't find any sum or prefix with the remainder that is already existing. So that means there is no subarray which is divisible by k. Okay, now we run it. So this is passed, right? No issues. Now let's try to submit the code. Let's see if it works or not. So you can see the code is failing. Let's pause for a while and try to think why is it failing, because we did everything right? Why is it failing? So I hope you tried to find the subarray. So in this one, 23, 2, 4 and 6 is the subarray, right? And we can see that k should divide all this, like the sum to this will be 35, right? But it is not doing that. Why? So if you can see, this remainder will be 0, right? But we did not have 0 already defined in our hash map, or like we didn't have any condition described for the 0, right? So when the sum will be 0, what will our program do? So over here we were checking if remainder is in HM and then the absolute, but this statement went false. Now what? So there are two ways to do it. One is that in our hash map we shall define the zero already, okay, that we already have a zero, and it goes till -1, okay. And now let's try to submit our code. So now you can see there's one more error. So we have 50003. So pause for a while and check why this error is coming. You can debug your code on your own, okay. Try to add some print statements and figure out why this error is coming, okay. Now if you found the source of error, you will see it is in the line 17, right? But this is conventionally correct line, right? If the remainder is in HM, like in your hash map or dictionary, then if it is true, then it will go to the next statement, or else it will go to this statement, right? Now think of it in a way like your starting sum is 5, right? It is not in your hash map, so you add it here. Now the second is 5 plus 0, 5 again. So now it is in your hash map, right? But can you find this statement getting true in any way? No, right? Because your current index is at 1 and your hash map of 5 is at 0, right? The 0th index. So 1 minus 0 is not greater than 1. So again it will move to this statement and your remainder will get updated, the index will get updated. So to tackle this, don't do anything, just make it a completely different statement, okay. And then else you can put here pass, or like you can leave it in like anyways, okay. Now when you try to run this, your entire thing will pass, right? Now if I submit it, this is submitted and I'm getting comparatively good, not comparatively but yeah, good runtime. But if you are doing in some other language, the runtime will be far better, so it will be around 1 to 10 ms between that. So yeah, I think this is much about it. So if now next step comes is I have to tell the time complexity and the space complexity, okay. So the space complexity here will be, you tell me, like pause the video and try to figure it out. But right now the space complexity, I'll say it will be big O of n in a worst case scenario, okay. And your time complexity will be big of n because you're just only using one loop. Why space complexity will be big of n in worst case? Because we have created a hash map or dictionary in which we are storing the elements, okay. So yeah, I think that's pretty much about it. So if you find any issues or like if you have any doubts, please feel free to ping me in the comment section, or you can connect with me on LinkedIn. I'll post it in my description only. But yeah, I hope you enjoyed this video. There was some like I had to take like I'll be completely honest, I had to take some pause in between to debug the code and find the correct explanation. So I think you will find one thing or another in between the code, okay, between the video. So yeah, I hope you enjoyed it, and I hope it really helps you. Thank you, and I'll see you in the next video. Thank you, bye.